For this example, we have the function y as the rational function in the form of x squared minus x plus 1 divided by x squared. Our goal is to find f prime by two different ways. The first way, or in part A, we're going to use the quotient rule. The second way, or in part B, we're going to simplify first by using the negative exponent before we find the derivative. So let's work on the first way, or part A. Apply the quotient rule. Recall the quotient rule. The y prime is the low d high minus high d low. Draw the line and low squared, or in a form of the g f prime minus f times g prime divided by g squared. And our case, y equals x squared minus x plus 1 over x squared. We treat this as the high as a top function and low as a bottom function, or f on the top and g on the bottom, either one. I'm going to stick with the high and the low function form. So with the prep work, we call it on the side, we're going to make a list what are our high and low function. For the high function, which is the function f, is the function x squared minus x plus 1, where the function g or the low function is x squared. So the f prime or the d high is 2x minus 1, and the g prime or the d low is 2x. We got everything that we need for the formula, and we're going to bring it back into the quotient rule formula. Replace the terms. The L or the low function is x squared. The d high is the expression 2x minus 1, and subtracted by the high function, which is the quantity x squared minus x plus 1, multiplied by the d low, which is the quantity 2x, all divided by the low squared, which is the x squared, all squared. So make sure you copy everything correctly. And then the next step, we're going to simplify as much as we can. What we see so far, we have the x squared and the 2x. We're going to take out the common factor. As you see x squared as x multiplied by x. The 2x is 2 times x. We're going to take out one factor of the x from these two groups. So we're going to have x out, and then inside here we have x multiplied by 2x minus 1, subtracted by, I'm going to write 2 in the front for our convenience, and all divided by x squared, that becomes x to the fourth. And next, simplify a little bit more by distributing x to the group and also 2 to the group for the last expression there. So x times 2x, we get 2x squared. X times negative 1, we have minus x. And minus 2 times x squared, we get negative 2x squared. Negative 2 times negative x becomes positive 2x. Negative 2 times 1 becomes negative 2. And all divided by x to the fourth. As you see why we're working on this, the x and x to the fourth can be reduced to be x to the third. And then for the terms inside the bracket, we have 2x squared minus 2x squared. These two can be cancelled. And negative x plus 2x, that becomes positive 1x. So we have positive x and also the constant term. So we have x minus 2 divided by x to the third as the derivative of the y or y prime by applying the quotient rule. This is part A. So the next part, we're going to simplify and then use the negative exponent before we find the derivative. To do that, so I'm going to use different color here. So for part B, we're going to simplify first and then use the negative exponent and then find the derivative. from our function y equals, let's see the function again, x squared minus x plus 1 divided by x squared. X squared minus x plus 1 all divided by x squared. We got every term correctly. So the problem asks you to simplify. That means from what we have here, since we have a single term as a denominator, we can write it as x squared over x squared minus x over x squared plus 1 over x squared, because we see this as the numerator sharing the same denominator, or the common denominator is x squared. So we just rewrite it as term by term. And then we're going to simplify. When we simplify, x squared over x squared, that gives us 1. Negative x over x squared, that is negative 1 over x. And the last term is 1 over x squared. We are done the first checkpoint here. So simplify. Next, we're going to write as the negative exponent. How do we write in the negative exponent? Recall the negative exponent is the reciprocal of the opposite exponent. So this one, it can be written as the one term, no change, but the second term becomes negative x to the negative first. The second term becomes x to the negative second. Now, our function rearrange into the form of 1 minus x to the negative first plus x to the negative second. And recall, our goal is to find the derivative. So we're going to work on finding y prime. In this case, we don't need the quotient rule because we don't have the quotient form that we can apply the quotient rule to find the derivative. We're going to need the power rule. Okay, because we see 3 terms and each term in the power form. So the derivative of the 1, we get 0. Derivative of negative x to the negative first is negative, multiplied by negative 1 as the original power. And then x to the power negative 1 plus negative 1 minus 1 becomes negative second power. And then the last term, the power negative 2 becomes a coefficient. I'm going to write it this way, plus negative 2, and then multiply by x to the power negative 2 minus 1, which is negative 3. Now, we simplify a little bit more. So y prime equals negative times negative becomes positive, which is just positive x to the negative second. The last term is negative 2 times x to the negative third. We have the answer in the form of x to the negative second minus 2 times x to the negative third. But if you rewrite in the fraction form, let's see if we have the same result as the other way that we did by using the quotient rule. So recall the negative power is the reciprocal of the opposite power, opposite side of the power. And then the second one is negative 2 over x to the third. Okay, it looks nice. So now if you go back to the red box here as the answer form of the first way, if you rewrite it, this is x over x to the third minus 2 over x to the third. You simplify more, we get 1 over x to the second minus 2 over x to the third, which is the same result, but just in different forms than the other way that we did. So you have 2 different ways to handle this problem or to find the derivative of this function. Either treat it by using the quotient rule directly or simplify and use a negative power form. Find the derivative by using the power rule as a second way.